Good morning. I'm Anil Agrawal from Aerospace Corporation. Welcome to session number 14, panel discussion on embracing the rapid rate of change. We have esteemed panelists here, 6 panelists representing different aspects of industry, academia, and you will be hearing from them. Our panel moderator is Marilee Wheaton. Marilee Wheaton is currently a System Engineering Fellow in the System Engineering Division of the Aerospace Corporation. In this role, she leads multiple collaborative cross-organizational teams aimed at developing innovative, resilient architecture, assessing new model-based system engineering process, and assist in establishing knowledge management system. Marilee Wheaton is an aerospace educational fellowship program studying in the PhD program in astronautical engineering at the University of Southern California, Bitterview School of Engineering. Marilee has held numerous leadership positions related to ground system, including the National System Group, Ground and Communication, the AFSC and Engineering and Integration, and General Manager of Computer System Division and the System Engineering Division. Marilee also held numerous positions prior to joining aerospace as a director at TRW Systems, now I think Northrop Corporation. She's a fellow of AIA, fellow of INCOSI, and fellow of Society of Women Engineers. Would you help me in welcoming Marilee, the moderator for this panel? Marilee.
Thank you. Welcome again to everyone here on our final day at GSAW, and I'll have to agree with Anil. We have a very esteemed set of panelists today. The format is going to be primarily all questions-based. So I'm going to start out by introducing each of our panelists, and I'm going to ask a first question of them, at which point they'll give a few minutes of an opening statement, and then, though, we are going to be getting into questions that you would have for our panelists. So while you are listening to the intros, you know ahead of time who's on the panel, take the cards that you have and start writing questions, and we'll have folks that will be picking them up. Neil, we will be responsible for providing me with the cards of the questions, because we would like to cover as many questions and get them answered that you have here. Judging on past GSAW, we've got really great questions. I know that they're out there, very discerning, that can really draw out the perspectives of our panelists. So encourage everybody to think about that and write down what would you like to hear from this esteemed group. So I'm going to get started. Make good use of the time we have. Our first panelist is Colonel John Antonin. He is currently the Director of Advanced Systems and Development Directorate, and he's also commander of the SMC Detachment 1 out of Kirkland Air Force Base. The mission of the Directorate is to deliver responsive space capabilities to users across the national space security community, and also for developmental planning, science and technology, and pre-systems acquisition for SMC. And as you heard General Greaves talk about it in his keynote on Tuesday morning, he is also leading within AD this new prototyping activity for enterprise ground services, which of course is very directly related to the charter here at GSAW. Previous to this position, Colonel Antonin was the Director of Operationally Responsive Space Office in Kirkland Air Force Base, providing timely satisfaction of Joint Force Commander needs through those ORS satellite capabilities. So you can see he's an excellent match to our theme of embracing the rapid rate of change. Colonel Antonin is an engineer. He got his doctorate in aeronautical engineering from the Air Force Institute of Technology at Wright-Patterson Air Force Base. What I would like Colonel Antonin to mentioned in his opening comments are, is what approaches do you believe would facilitate SMC's engagement with industry counterparts in order to allow rapid, cost-effective development of ground systems to support future missions for SMC?
Thank you, Marilyn. So it's an honor to be here, folks. This, I think, is my third GSAW, where I've had a chance, second time I've been on a panel. And in that time, we've seen a huge change in the nature of the questions we're asking ourselves. And so at the first one that I was at, we were talking about, well, how do we move into the information age? How do we change the ground systems? How do we get to a new and open architecture? And now the question is more about, well, we've done those steps. How do we allow industry to be more effective with us? How do we at SMC be more effective with industry? Because one of the biggest things people have seen over this period of time is everybody sees the need for change. Everybody sees the opportunity for change, but no one's quite sure how to get into that last step of change. And everybody's wondering, where do they step in? How do they participate? How do they become a part of it? And so in that period of time, we've learned a few things as well. The government's really, really bad at helping industry do this. So we can write contracts, and we've done it, that will allow you to build the greatest 1990s ground stations in the world. And you'll deliver to them, to us, and we will check off all the requirements boxes. And we'll all look at each other, and we'll shake our heads and ask us, well, how did that happen? And that's really the heart of the question, I think, is to get around allowing that to happen. And so we think the ways we can do that is really looking inward first, and some of the things that General Greaves talked about is changing our own behavior. And so part of it is working with industry on breaking up the problem so that the decisions we make are actually small enough and affordable enough to allow us to take risk and embrace change. And so when I'm making a $1 billion decision, the government is notorious for saying, well, I'm not going to risk anything. I'll take that 1990s ground station because I know it works and we'll press on. But if I'm making a $100 million decision, like we were doing at ORS, the decisions were easier. We were able to make quicker advancements. And we're making a $10 million decision. That's even easier. It's pressed down to a lower level. That's a lieutenant colonel. And when it's a $1 million decision, everything changes. And so the opportunity that we are looking for industry to do is to help us get to those decision points. And so when people talk about enterprise ground, I think there'll probably be a few questions about that today, and how they participate in it. Where is that enterprise ground contract that I can go win? We want to change the story with industry in the discussion. We want you to help change it with us. And so when we look for application-driven systems, we look for management of networks or computer network defense, we want to make those decisions separately within an architectural framework that allows them all to work together. And so what we would like to do is encourage industry to think about how we approach it. The contracting actions we can do to make those smaller decisions more rapidly and to encourage change. So those are the kinds of things we'd like to see. That change in behavior is on the government's part to a certain extent, and how we approach contracts and what we do, but also with industry and how they approach us and the things that they offer us. And so this is intended to be a two-way street. I hope everybody got a chance to see the wiki that's out there. Talking to industry, because that's how we want to communicate in a very rapid fashion, in looking at new things and changing the question. The question shouldn't be, how do I win the 1990s contract, which isn't going to exist anymore? Instead, how do I step into a new contract where I'm making advances very, very quickly and decisions at a much lower level and a much lower cost?
Very good.
Thank you.
Thank you, Colonel. Our next panelist is Rishabha Maharaja. Rishabha is currently the Deputy Flight Operations Team Lead for the EO-1 mission at NASA Goddard Space Flight Center. He's also an adjunct professor for the Astronautical Engineering Department at Capital Technology University. Rishabha received his Master's of Science degree in Astronautical Engineering from Capital Technology University, and he developed the concept for Project Hermes at CTU, and he was the principal investigator for Project Hermes. Rishabha and his team broke new ground with the use of Wi-Fi, smartphone technology, and other commodity consumer technologies on board. And as everyone got the announcement this morning, he was the winner of our best presentation for use of smartphones for receiving telemetry and commanding a satellite. So the question I have for Rasaba is, in thinking about the cultural difference between your roles, both working for NASA Goddard, which has certainly some of the more traditional approaches to our business, as well as thinking about what you do with Capital University, Capital Technology University, how do you see that cultural difference and your perspectives on that?
So first of all, it's an honor to be here. Thank you for the great introduction. So yeah, as she stated, that I do have two different hats. My 9-to-5 job is to fly a satellite, the EO1 spacecraft, and in the evening go teach at Capital Technology University. So yes, you do see two sides of very different cultures. Goddard is very much more of evolutionary, but on the college side, we can actually be revolutionary. But I can apply what I know at Goddard at the university, and hence Project Hermes. Despite the fact that it was a smartphone, I had to apply all the things that I know as a flight operator and push it downward. So the cultural change rather at Goddard is, of course, we're flying multi-million-dollar, multi-billion-dollar satellites, so we can't really apply a lot of the revolutionary technologies. But at the same time, I so far haven't seen any place where we can just tinker with toys. You know, we're obviously just putting out there for proposals and trying to apply for different methodologies. But at the university, we can actually go out and tinker with toys. So to sort of answer the questions about the culture is, I really do feel like the government or the industry in general, big companies, institutions, should just have a very small budget tinker with toys department, and where we can actually just go out and apply just whatever our ideas in our head, and that way, you know, with a very small budget, try to execute them. If they work out, they might be revolutionary, but in turn can help the evolution of the space industry. So I'm not, completely saying we should completely revolutionize everything, but the small revolution does in turn help out the evolution at the end of the day.
Thank you, Rasaba. And also, we do have, just so folks know, we do have also separate forms. They're in the aisles, so if people are interested, the folks in the aisles with their hands up have the forms. So if you would like some of the forms for questions, let them know. Okay, our next panelist is Mr. Michael Moran. Michael is the Director of Government Solutions for Intelligence Community and Air Force Programs at the Harris Corporation. Prior to joining Harris, Mr. Moran served in the United States Air Force. He was there for 26 years. He had command assignments at the squadron, group, and wing levels, and his Air Force career was spanned global space, launch, cyber, airborne, as well as foreign military sales programs, and he worked for a number of organizations providing leadership as an Air Force officer for the NRO, Air Force Space Command, the Pentagon, and NATO. He holds several masters. He's an engineer, Masters of Science from my alma mater, USC, go Trojans, and also a Bachelor of Science degree in Mechanical Engineering from the University of Virginia. So the question I have for Michael is, given that your background to industry, what do you see as keys to enable the rapid rate of change for organizations such as SMC's Ground Enterprise?
Thanks, Marilee. I appreciate that, and as a chance to participate on this esteemed panel. All the things I wish I knew when I was on active duty, my goodness. I think first and foremost, I always thought that I was communicating so effectively, that I was providing very clear communication, what the programs were and the end states were, and I realized that when I went on a 2-week vacation and came back to my office, I was in a different environment. Somehow in that 2 weeks, everything had changed. And the dynamics of the environment in which we work, all of us work, and the opportunities demand we really pay attention to the communications and the criticality of communications. The thing I am very much tuned into now is I'm listening for different words and different points than I had on the government side that I was trying to communicate. So very clearly the mission-based outcomes, what are we trying to get to support our customer base? And in industry, it's defense, civil missions, commercial missions. Each one has a different customer pool set, with a different message and a different mission space. But what I found as I put on the corporate industry hat was I started listening with the, where's the business case? And so I would listen for when things were happening. How big was the addressable market? I would look internal to the capabilities that my company had and the companies that I would partner with to try to bring unique capabilities and quick capabilities to the benefit of the customer, and make investments then that drove toward that end. So when I looked at the investments, every time I got to my boss, he'd be like, okay, great idea, we clearly could do that. Is there a business case that leads to that? And I think that communication dialogue demands innovation in how industry thinks of the business cases, because the business case of the old win the grand $1 billion something, that does not allow the agility that our enterprise offers and that our customer base demands. So you still need to understand the wins in the house and where the customer base is trying to go, but some clarity both from government and with industry back and forth that drive that business case helps me to drive investments in a way that will ultimately have some returns. So the communication, I think, is just a critical enabler to moving rapidly forward. And yes, I'm an engineer, as mentioned. How many folks are technical in the room? How many folks are not technical? So I'd offer that our way forward is technology enabled, but not inherently a technical problem. And I think, as Colonel Antonin and others have suggested, how do we create an environment that accelerates through those kind of things? You know, how do we create the mission marketplace where there is agility, where the mission customer needs that agility, and stability in the places where they need security and stability? And I think we heard during the discussion, you know, the presentation layer that would be a defined interface and set of standards that would allow agility above that for our customer's mission space, and below that, where the customer may not have particular interest, and Frank mentioned the stuff that military folks may not find militarily relevant, those are a perfect place for industry to roll in and help to pick up that in a risk mitigated way. So I think there's a great opportunity to look at our muscle memory of culture. We sort of, all of us on the panel, it's not our first day, so we sort of think of things the way we've thought about things. And as noted, innovation demands something different than that. So looking at the whole system in a different way is critical. And in the meantime, we'll continue to be in the world of hybrid environments. We want to generate, as she was talking about, agility where agility can bring new opportunities, and we still have militarily critical infrastructures that are large and substantial, which will move more slowly and sometimes with good reason. How do we look at that architecture in a way that allows agility for new and a vector, and then using that vector as a point of convergence for baseline programs? So as I move into and as I moved into the entry lane, it's the challenge of the journey in getting there, where you're protecting the mission critical capabilities and creating innovative opportunities for new and migration has been really a critical enabler for us.
Thank you, Michael. So as you know, GSAW is an international community, and we always are very pleased when we have someone from our international community that's here on our panel. Today we have Senor Jorge Podi, who's from GMV. Jorge is an aeronautical engineer, graduated from UPM in 1986. He also has a management development program certificate as well. He then joined GMV right after he graduated in 1986, and since 2009, he has been the general manager of their space division, their space portfolio of GMV. So he has always had his career linked to GMV, but he's had many different jobs, starting at the project engineer level, then project head of some of their programs, then manager of the control center unit, the commercial manager, and now in his current role as general manager of space programs. So the GMV company, if you're not familiar, it's headquartered in Spain, Tres Cantos, España. It has 1,100 employees. He himself runs a team of nearly 500 engineers that reside in 10 different countries. And again, all employed in the space sector, looking for leadership related to ground systems and related areas. So as part of his company, he has done work for both NASA and ESA. And so I wanted to ask Jorge, as part of your experiences in working with very different organizations such as NASA and ESA, as far as the rate of rapid change, what are your experiences in terms of that, and then using innovation to support these different customers?
Okay, thank you, Marilee. It's a great honor to be here, so thank you very much for the invitation to come. And yes, we as a company, we started doing ground systems for the European Space Agency. That was our first customer 30 years ago. And it was 12 years ago that we incorporated a company here in the US and started working in NASA programs. So we know a bit about these two, say, animals. And in addition to this, we've been successful in developing ground systems for the commercial space market, particularly for telecommunication satellite operators, which my first reflection in this initial speech is that I would like to see more of commercial telecommunication operators here in this conference, and I think it's important that they are. It's clear that the main driving force of the ground systems for space programs are the government agencies. It's clearly much larger, and they are dominant in our industry. But the commercial space market, I think it exists, particularly telecommunication satellite operators. We serve many of them. We serve like 30 satellite operators. And one reflection I wanted to mention is that there is an innovation that seems to be coming, well, we've seen that 15 years ago, but this time might be the right time. I'm talking about mega constellations, and these are completely new, innovative programs that they seem to be knocking the door again, as I say. We're talking about thousands of spacecraft. This is a real radical change to our industry, and that poses challenges, not only from a technical point of view, which is already a very big challenge, but also from a business model point of view. The cost challenge is enormous, is huge. I'm talking of constellations like OneWeb, for instance. This is 1,000 spacecraft, 20 orbital planes. How to make a real-time system that is able to cope with that, how to define an operations concept that makes sense for such a large constellation. We've never addressed that. So this is the innovation, one big area that I see coming. And I think that we've been talking these days about the reference architectures, common technology that may serve general purposes. We need to take into consideration that radical things like these mega constellations, we need to take them into consideration, and that is an additional challenge for all this. So that was all for that.
Thank you. Okay. Our next panelist represents academia. Dr. Jordi Puig-Suarez received his bachelor's, master's, and PhD degrees in aeronautics and astronautics. Hey, we're kind of a theme here. We have a lot of aeronautical engineers on this panel. From Purdue University. Jordi is a professor in the aerospace engineering department at Cal Poly SLO, so just up the coast from us here. We're very glad that he came down to join us. In addition, in 2011, Dr. Puig-Suarez co-founded TIVAC Nano Satellite Systems to support the commercial CubeSat market, and he's currently TIVAC's Chief Science Officer. In 1999, Dr. Puig-Suarez and Professor Bob Twiggs at Stanford developed the CubeSat standard. So that team was responsible for the development of the standard CubeSat deployer, which is called the P-Pod. And he has supported launches for over 100 CubeSats in the US and abroad using that deployer. The customers include universities, NASA, ESA, National Science Foundation, the DoD, Boeing, and also aerospace. Aerospace, as you all may know, have a very robust CubeSat program as well for our customers and have used the P-POD system. In addition to launch activities, Jordy has been involved in the development and launch of CubeSats through the university, and he's currently working on, he said, 4 CubeSats that they have in work right now at Cal Poly SLO. So the question I have for Jordy is, what are the implications and challenges of the increased access to space? So for example, using CubeSats or this cheaper space launch, and what implications and challenges does this increased access to space have on ground system community?
Thank you so much for having me here, and I'm representing academia. I've worked with the NASA's and the DoDs and all that, but always from an academic CubeSat, small, that toy box where we can do things. So a little different than a lot of the people in the room. The first thing that I want to put on the table is that it's very interesting what's been happening with CubeSats. You know, we see them as revolutionary, not necessarily in that they're small, but in the way we utilize them. They're fast, they're low cost, they're high risk, very low lifetimes, but very innovative technology. We're always putting up the latest COTS, you know, cell phone based technology. Some people would say we're disruptive, other people would say we're annoying. But what we're finding is that we're finally gaining acceptance. We're getting flights. Right now, almost every rocket in the inventory worldwide can carry CubeSats. But one of the big things that we're finding is that the technology is faster than the paperwork. And that's been a huge challenge for us because the infrastructure, and I like the question about how many people are technical and how many people are not technical. For us, the non-technical barriers are becoming more significant than the technology. We can build a satellite in 12 months. We built a satellite at TIVAC in 4 months. But we had to get frequency allocations for those spacecraft. That's very difficult. Creating ground software is very difficult. And a lot of the commercially available systems that are accessible, they're not designed to move that fast. And their cost parameters are not compatible with something where the spacecraft will cost $200,000. So that's a place where we really are finding a challenge that the infrastructure in place is designed for systems that will last 15 years, that cost $200 million. And it's totally correct. That's what they should cost. When I'm watching the Super Bowl, I don't want DirecTV to go away. So I want that satellite to be really reliable. You know, if somebody's running the nuclear codes, I want that satellite to have 4 levels of redundancy and all that. But that's not all there is. And what we're finding is that the infrastructure at the ground, at the regulatory levels, is not set up to service the smaller part of the industry. The one thing is there's not a lot of money in it. They're very low cost, which means you're not going to get a lot of billion-dollar contracts doing CubeSats. So the attractiveness to some of the industrial infrastructure and the know-how and the people that really know what's going on, it's not really attractive. It's growing, and I think we'll get there. And OneWeb, if you think about it, they're really inexpensive satellites, but they're building 1,000 of them. So the numbers start getting higher. So I think we're converging to the point where the challenges we've seen on the CubeSat side of things are moving over to industry as the whole CubeSat revolution goes from .edu to .com. And there things are getting interesting. And one of the things that I also want to say that it's very interesting, we're kind of watching it from the university. The training and the mindset that the students are getting from CubeSats, their expectations at how fast things need to happen are very different from what they find out in industry. And I think that may be one of the realizations that it forces them or pushes them or encourages them to do a lot of the starting up that's going on with small companies like Planet Labs. You had Ames people starting Planet Labs. And it's looking for this new place where I can play in this new, faster, more aggressive way that the traditional industrial base is not supplying. So we see that as a challenge all around, but the ground is a big part of it.
Thank you. Lord Jordy. you just came down to GSAW today, but earlier in one of the sessions, we actually had Rob Anzac, who exactly that point, the kind of too big to succeed, and he was talking about the weight of the infrastructure versus the technology. So it's interesting, kind of, you brought that full circle now here as far as your comments for the panel. Our next panelist and sixth panelist is Mr. Tom Soderstrom. He works at JPL. He is their Chief Technology Office at NASA's Jet Propulsion Laboratory. In that role, he leads a very collaborative and hands-on approach with JPL and industry to investigate emerging IT technology trends that are relevant to JPL, NASA, and large enterprises, and then to infuse those best practices into JPL's environment. Tom has led remote teams in large-scale IT best practices and tools development, and also change efforts in small startups, large commercial companies, in international venues, and also in the U.S. government arena. Tom serves on many industry and government advisory boards, steering committees, and award committees, and he's also a future speaker on the future of information technology. And he is currently consulting with industry leaders on where the federal government and industry are headed in information technology. So, Tom, given the rapid pace of change in the IT world, what IT trends and future directions will have the most impact relative to ground systems and their architectures in the near future?
Well, thank you for having me here today, and I will talk about IT, but as you hear IT and technology and our future is merging. And my title is now Chief Technology and Innovation Officer, because it's all about the pace of IT. We're used to fast changes, and the rest of the organizations have to be have those fast changes too. And what Jordy just said about the paperwork needs to keep up with the technology changes is absolutely true. So what I look at is JPL is, and you've heard from many JPLers today, it really is an 80-year-old startup. It has that entrepreneurial culture, so it's bubbling all the time. And as we learned how to do big spacecraft, big missions, we learned how to put a rule book together, and that rule book is changing, and we have to figure out how to change that. Our credo is to dare mighty things, which is good, but dare mighty things and succeed. So now we have to also learn how to dare mighty things and be ready for failure. CubeSat is a good example, where we can use CubeSats to fail in small ways and iterate our way to perfection. So as I look at the IT trends, what we did is we looked at IT decades. Anybody know how long an IT decade is?
2 years.
3 years. You're close. 10 human years is like 3 years. And there is a generation change between a freshman in college and a senior in college. They think so differently. Facebook is so yesterday. So as we look at, it's really about what is innovation. Innovation is about infusing a new capability to the people who need it and without wasting too much time and effort. So what that really means is we look at the consumer and IT trends that change very rapidly. If you go to a Consumer Electronics Show, who's been to Consumer Electronics Show? Just curious, show of hands. 1, 2, 3, 4, 5, about 6 of us. Go, it's fun. And you will see, it's a petri dish of experiments that will come into your environment. So they change very fast. The human behavior trends change more slowly. What will we adopt? What will we be able to adopt? And if we're not able to adopt it, why bother prototyping it? Now, the organizational trends, the enterprise trends, change the most slowly. So what we focus on is the consumer behavior trends, because we know we can make a difference there. And the ones that are coming in this next IT decade, the next 3 years, are, and I'll rattle them off, but the key point here is we experiment with all of these. We prototype with our own data, and we tell the story. We partner with startups. We partner with big industry vendors, and try it to see if it makes a difference. So the ones that are coming that people are ready to adopt in our enterprises are smart data. Big data, it's so yesterday. It's about doing something with the big data. It's about the analytics. It's about the metadata. It's about having a data exchange that you can pull in all the data. Open is scary for most of us, but it's beyond open source. It's about open development. It's about sharing the code between the various business units inside the enterprise. And rapid prototyping. Rapid prototyping is going beyond software. It's agile development applied to everything. It's about having Raspberry Pis, 3D printers, Arduinos, etc., and creating a makerspace for the people at JPL to experiment. And you now see software and hardware people and scientists and engineers working on the same things very rapidly. And CubeSats is a great example. We've gone from infusing crazy toys into spacecraft from years to a few months. And it's very inexpensive. And it's fun, it's energetic, and it's a good training opportunity. Cloud first. Cloud is the enabler of everything else. We have analytics clouds that are safe and secure, where people have a creative space to innovate in IT. Crowdsourcing. The crowdsourcing and maker movement is very real. And we are all in competition with the Googles and Ubers and Facebooks for talent. Having internal hackathons is one way of showing that we are with it. Work from anywhere and everywhere all the time. Internet of Things. Internet of Things is way beyond toys. If you look at the home consumer market, automation, can you use a Nest in the enterprise? Can you use Philips Hue in the enterprise? Can you tell Alexa to configure the conference rooms? The answer to that is yes. And is it a security threat? Oh yeah. Is it a huge impact? Definitely. So we are now experimenting and we figured out how to do that. And I can give some examples later if you're interested. Programming. Programming is changing. It's the decade of the programmers. And it's now they're targeting 4 to 8-year-olds. So when the next generation comes into our enterprise, they expect of configuring it all the time. And we should enable that. Natural user interfaces. You used to click it. Now you can swipe it. You can think it. You can blink it. You can approach it. That is how we interact with computing is different. So that's a trend that people are ready to adopt. Automation of everything, especially for our system administrators. We don't, with our big data and with the new cloud computing and on the scale, we can't have people tinkering and rebooting. We have to have the software. We have to build reliable systems from unreliable components, like Netflix, like Google, like Facebook does. Non-traditional partners. One of the benefits of the government is it's sponsoring space startups and space commercialization, and that's a great thing for all of us. And I think that's going to make us much better. Cybersecurity awareness. I mean, the OMB hack, who was affected? You don't have to raise your hands, but pretty much all in the room were. So people now care about cybersecurity. So we have done a green, yellow, red light with Philips Hue lights at JPL when there's a security threat. And we measure it all the time. And we can hear the firewall play the music. So in real time, there's security awareness. And lastly, I would say we're used to enterprise architecture. And now I will offend everyone. Enterprise architecture doesn't work anymore. We have to think about it differently. We think about it as chaotic architecture. We are building an architecture that we know will change. But we're not building it to last for years and years. One size does not have to fit all. And the next IT trend for the next IT decade is E4. Engage and enable everyone and everything. So you got crowdsourcing, you got maker fairs, you got Internet of Things. So those are the trends that we see coming. And then we're experimenting with all of them.
Thank you, Tom. So now you can see why I was absolutely just so impressed with this panel that we have up here. Just amazing opening comments. We have started getting some questions, and I'm going to start with those, but please continue to think of questions that you might have that you'd like to ask our panelists. Several of the folks have kind of talked about the need for change related to enabling this rapid rate of change, and certainly a lot of us and the ones in this audience start thinking about the acquisition process and what might need to change. Several of the panelists have talked about that. So the question is, how will the acquisition process and RFPs and evaluation criteria change to support rapid development with much more innovation? And we all know that the proposals that the customer gets is a reflection of what they ask for, how they ask it, and then how you evaluate. And also specifically thinking about what Colonel Antonin said about helping to decompose to smaller decisions. Obviously, that's related to innovating the procurement process as well, too. So I think for this question, I'll start with Colonel Antonin and ask him to address his thoughts on that, and then we'll get some other folks to weigh in, too.
So one of the biggest areas that has to change is the way we write our contract pieces. And so I know I can write a really bad contract, and I know you can respond to it. So part of what we need to do is shift out of extremely lengthy, requirements-driven activities and into a need-based environment. So I have a need, you have a solution. We should be able to work together to come up with how to test that out. And so you've seen a lot of innovative activities coming out of the CTO office in the Air Force and other areas. Plug test and things are like those things. And so you're going to see more of those types of opportunities that are out there. The other thing is that you need to be confident in industry that you understand the rules of the enterprise of which we're working in, and the rules upon how we're going to evaluate success. Our ability to communicate those two things right now in the government is fairly poor. And so one of the big things we're looking at, in particular for enterprise ground, is we're just going to make all the rules of the enterprise available to everybody. And if you're a decent programmer, decent builder, you can put it together in your garage, and you'll have a version of it. So you should have confidence in the configuration and actions upon which you'll be evaluated. And then communicating our need is the other part. So we're really bad at this, and one of the things we want to know in this area is that we don't know what we need. And so giving people the opportunity to bring in new ideas, new opportunities, new things is the other part of what we want to do. And so we're looking for opportunities to do that, and I don't know the answer to it today. I'm not sure how we're going to make that happen. And so we're looking for feedback from industry.
Thank you. Mr. Podi, do you have any thoughts related to the procurement of the systems?
Yes, in fact, this is acquisition is a very critical point. It's obviously, as I mentioned before, our ground systems industry is dominated by the government agencies, and their procurement policies really shapes what the industry is, in fact. So obviously, smaller RFPs give rise to smaller companies to shine, and therefore will create more innovation from a more natural way, say, as opposed that larger procurements will be in the hands of the larger companies, big primes or large system integrators, and that shapes the industry in a completely different manner. There is a cultural difference. ESA, in particular, has a policy of the ground systems not to be developed by the large system integrators. So there is a non-primes policy for that particular part of the procurement. And that allows companies like mine, like GMB, to develop itself and then to break into the commercial market. And that is, yes, as I say, is critically important, the acquisition process and how they are. And this really shapes the industry.
Interesting. Tom?
So just one point, which is SLAs. We all love to write SLAs. We need to relearn how to write them into SLUs, service level understandings, because the SLAs can drive the wrong behavior. And we hold the contractor to meeting those SLAs, regardless if we still need them. And it inhibits innovation. So rewriting that somehow and responding to it in some way that encourages rapid innovation and changes without punishing the contractor, I think is important.
Mike, you had a thought?
Yeah, a few thoughts, and it's an excellent question. The difference between need and opportunity, kind of the things that we think we need are based on how we thought and how we currently operate and use systems, and the opportunities that ahead allow the, hey, can you do that? Wow, that really has utility to me as a customer, whether it's a military, civil, commercial application. So having a development environment that represents that, I'll say both a legacy and emerging ground enterprise with free access to the smalls and the bigs, reduces a barrier for entry, but allows really everyone to play. It's not boxing anyone out, and it allows an adopt, vice, create dynamic to emerge. And if there is the ability, as Colonel Antonio has mentioned, for impressed consumers to say, I like that, I'll take it, you can create a mission marketplace in that environment where industry sees the benefit and will keep coming. If it becomes burdensome and slow and doesn't result in the ability to turn great ideas into capabilities that customers are anxious to consume, then it sort of dies on the vine. And I think the large audience here and many industry players are excited about the enterprise ground services dynamic and the changes that are here. And and they're interested to see how they can play quickly because, just as you shared, the ability to get in quickly and create that mission marketplace, I think will accelerate the opportunity space and bring more folks in who are willing to take that investment risk.
Good. Jordy?
Yeah, I just want to interject kind of on a different tack a little bit. But it's the idea that the procurement process and the verification and follow through of contracts, as is currently done at government level for big programs, it's incompatible with the numbers we want to see happen. And we've seen that with some of the licensing agencies. You know, the FCC, NOAA, they were set up to do 3 or 4 licenses a year. We hit them with 52. And they had to change their processes, and it worked really well. They streamlined things for cases where all that level of oversight was not required. And if we're going to say we're going to have 50 CubeSat missions for NASA, each one with different requirements going to a different place, you're going to spend more money keeping track of all the paperwork than actually flying the missions. And that's an interesting conundrum to have.
Actually, this next question is a little bit related to that topic, so it's a good segue. So with the current evolution in launch services as well as in CubeSats, in the very near future, we will be able to go from concept to launch in 6 months to a 1-year time frame. And the point is being made that this time frame is too rapid to develop a ground system, especially one that fits the traditional Air Force, DoD, NASA framework. So how can we have our enterprise systems allow for this rapid development? And is there any additional work that we need to do in order to accommodate such a rapid response to an urgent need? So maybe I'll have Jordy, you come in first, then I'm also going to ask Rispa here to think about that question as well too, from your experience.
Yeah, I'm going to be very brief because we are very ill-prepared to understand how to make that leap from the top to the bottom. I mean, the universities have done things from the bottom to as much as we need.
Right.
And that's one of the things that we've seen, that developing the little bit that you need to run a ground station for a small mission is not that hard. The real hard thing is to grab something that's very large and very well integrated and controlled and trying to reduce it. So one of the things that I would put out there is that maybe the way to do it is to just start from scratch. And that's a very scary proposition, but you start from scratch on a program that's, $1 million, or what Colonel Antonin was saying, something where, you're at the lieutenant colonel level or wherever that level is in the DoD, and try it. Because right now, if you want to grab the infrastructure you have and bring it down, you couldn't grab mainframe software and create the Macintosh. So we're kind of in the same place.
Actually, that's a very interesting point because, there's definitely something in the whole economics realm that and as humans, this idea of sunk cost, right? So we always make decisions related to sunk costs we have, and from an economics point of view, that is not a valid way to determine, the value engineering associated with something, but we do it time and time again. So, I mean, even as, potentially, crazy as that might sound, in reality, I think we have to think through some aspect of that. So any thoughts, Rispa, that you have?
Yeah, sure. I mean, my experience is slightly different. I was given $2,500 to pull this off, right? So it's completely different from a lot of the other personnel here. And so the way I did it was, as mentioned, we have to start from scratch. So I knew that I had a very small ground system to play with. I didn't have money to develop something big, right? So therefore, I approached the problem from the spacecraft's point of view. So hence the TCP/IP was much more, it made a lot of sense because then there's a lot of compatible devices out there that I could use. So in order to maybe have a reduced time frame and maybe a very small budget, yeah, I do agree. I think we just have to sort of start from scratch and then go from the bottom up. Maybe rethink the spacecraft first and then influence a corresponding ground system. So that's probably what I would argue, rather.
Colonel Antonin, certainly you have been thinking about this related to the piloting that you're going to be doing, so I'm sure you have some thoughts on this as well.
So radical change comes from radical behavior. It has to. And Jordy and team are certainly people that have made that happen over the last 10 years. When you get into addressing military requirements, radical change is not really high on the list. And so how do you sort of balance those two things? And so attacking essentially a clean sheet solution, I went about it a little bit differently, and perhaps the same way. And my team will remember, you don't build anything you can steal. And so you steal as much as you can. So we stole from Goddard, and we stole from Jordy, and we stole from a number of folks out here. Open ideas and open system architectures. And so when you do that, it allows you to address both sides of the question. How do I innovate rapidly using open systems? That gets you moving and makes you leapfrog things very quickly. And then you can start to address the question of military utility, and you can start dealing with the reliability and things that you want to do when you're dealing with the, like Jordy said, some of the nuclear code systems. And so trying to balance those two is really important for us. But there are certain things that eventually you're just going to break. And having the courage to step forward and do those are very important. You know, my team and I talk about this a lot. I have no desire to be the most respected ground system developer in the world. I do, however, want to change the world. And so if you listen to General Greaves and General Hyten, you'll hear the same things. And that means we will break some things in the future.
So one of the questions that comes up a lot in terms of, thinking about systems is this balance between the role of government and the role of, commercial. And so one question we received was, what should be the role of government in development of ground data systems of the future? And is there some sense that there could be a set of common services? Here at GSAW, over the various number of years, we've certainly talked about common services related to government industry that could maybe be made as open source software to all. So would anybody like to comment on that, Tom?
Yeah, we're wrestling with that right now, actually. And as you look at the big data, what we traditionally do is we take, in the ground system, we take the data and we move it to somewhere where it's processed, and then the public can get to it. Now, the next few missions we're doing are, depending on how you count, 40 to 10,000 times bigger than anything we've done before. With that, we cannot move the data to the processing. We have to move the processing to the data. So how do you do that? And how do you have to use commercial clouds? How do you interact between clouds? Open source and the way open source moves forward is much faster than the way government tends to regulate. So there's a big need there. I don't know what the answer is, but I wish I had the answer right now. So having an RFC type infrastructure where we move things forward in piecemeal, and I think government's role is to inspire innovation, and it's to inspire innovation, not to regulate innovation. So there's something there that we need desperately, and there's a lot of business opportunities for many people.
Jorge?
So, well, in our case, we GMB, we in fact we took ESA technology, and based on that we developed a commercial product. So the answer is that if the government ground system technology is applicable to the commercial market, the answer is yes, although there is a significant level of investment you have to put on top of the government solution in order to be able to address the commercial market that has completely different needs, completely different timescales, and completely different acceptance of anomalies and issues in the software. So the stability is a must. Our commercial satellite operators expect the system to be up and running for 15 years, full stop, and that's it. So the answer is yes. Now ESA is trying to promote an idea that goes a bit further in this idea of trying to develop a common core that will serve general purposes of mission control systems. The idea is very ambitious. We need the industry to figure out how to build, and this will be like a sort of open source community. And we, the industry, we are expected to develop on top of that, or that kind of community source that ESA will be promoting, which is actually being implemented at these days. Now, how to build a business case that makes sense for an industry like us on that? this is something to be seen. And whether it is compatible with the timescales of the commercial market, with sometimes radical changes, like the mega constellation that I mentioned before, that make you have to completely modify the core of the system because the existing system is not valid for performance reasons or whatever. We've seen that in the past, and this is one of the reasons why we diverged from the original ESA technology. So the answer is that yes, it's possible, although the business case closing, it's not straightforward.
Interesting. Mike, you probably have some thoughts on this in your role of first being with the Air Force and now transitioning to industry in terms of the role of government versus commercial.
Yeah, I was definitely convinced the Air Force could take care of this on its own. Just kidding. So I think that one of the challenges that we're facing is resiliency in our architectures and in our capabilities. And so I think there's benefits in hybrid solutions, vice replacement solutions, because we want to have both the agility in certain aspects where we can accept some risks and see some opportunities while we're sustaining, delivering, and converging legacy toward that similar end on a risk-mitigated, risk-managed timescale. So I think the delicate balance is one where, government definition of should really be a government facilitation of the common standards, and I see that throughout to great advantage. But in making, as Jorge notes, the business case, control and ownership of aspects can dramatically swing the business case. And so there's some, I think, some critical dialogue to talk about ownership of certain aspects. You want to make sure you have a competitive environment, but that business case closes when there is a future for those products that are uniquely invested in. So it is a bit of a balance, and creating an active mission marketplace where that benefit exists and looking at that open architecture where there's benefits that industry can bring in is, I think, a good spot. And lastly, I'll offer that it depends on your mission. If you are a SATCOM mission, that boundary and interface to accomplish your mission might be different than if you're in a hyper data intense Earth observation kind of dynamic. There might be a different point where that synergy or that mission-based definition exists.
Yeah, respond.
Just wanted to add to that. The hybrid approach is excellent, and I sort of mentioned that in my presentation, is that, if we had these radical ideas and if we sort of tagged along with the big banner missions, it allows us to do a lot more, because with these radical ideas, of course, the first thing we're going to be asked is, is it radiation hardened? I don't know. We won't really know until we try it. And so therefore, once we do try it in the hybrid environment, we will know a lot more about it. So then that will eventually lead to better and better and, I guess, someday cheaper systems.
Thank you. Jordi, you had talked about how your team shifted from playing with toys to then determine, a need for the standard, that wasn't developed then a number of years ago between you and Stanford, the Peapod. And so kind of in that process of first, kind of doing it for, the enjoyment of it, and then realizing, that there actually would be something, more standardized that then could be beneficial to the industry. What did you do, in order to develop that to enable you then to continue to be able to play with toys, but do it in a much more efficient way? So you want to comment on that?
That's a very
process?
interesting question. I mean, do we have an hour? No. The one thing that we saw is the universities were playing with satellites for a long, long time. The big difficulty was access. We couldn't get them up.
Right.
And we needed a way to put them in space. And one of the things that a lot of people were doing is we were complaining that industry didn't have enough respect for us. We said, our students are really good. We're building really big spacecraft. Why are you guys so mean to us about being a risk to the primary and all that stuff? And what we decided is that was kind of a stupid approach. And we decided the primary is worried about their safety, the launch vehicle is worried about their safety. Okay, I'm going to put my satellites in a very, very heavy box. I'm going to qualify the heck out of the box, and I'm going to kind of change the conversation and say, here is my solution to protect your primary and your launch vehicle. And that was a critical mindset change from the university perspective to go from a competitive or confrontational approach to a collaborative approach. And I think that And then the other thing that was important was to minimize the things we standardized. We said the size is standard because you need to fit in that box. Don't put explosives or dangerous stuff. Other than that, knock yourself out. Try anything. And that worked really well.
Yeah.
And one of the things that we have discovered is that there is a tendency to be confrontational with regulators, the government, the people who write RFPs, and just tell them they're wrong. And that's very satisfying, but it doesn't get you anywhere. So one of the things that we have found is that collaborating and engaging those communities is a very positive thing. When we went to do the first launch in Russia, the first phone call with the State Department, we told them we're putting 14 satellites on a Russian rocket and we need a license. They laughed us out of the phone call almost. But we really insisted, and they became really friendly to us. And everybody was telling us how horrible ITAR was, and the State Department, they're the ogre that comes get you. But once we engaged, they were very effective. NOAA came to us and said, you cannot put imagers on CubeSats because you need these NOAA license. And one option that a lot of people took was to say, the heck with it, they're wrong, we don't want to do this. But the solution was to go to NOAA and say, these are really bad imagers. Do you really need 15 pages for everyone? And they say, no, we cannot read 15 pages for everyone. Put in one page. And we worked together to get that one pager, and that worked. So I think that that's one of the important things, that sometimes people look at us as these crazy revolutionaries that we like radical behavior, But we were very engaged with the regulators and with the government to try to make sure we succeeded. They were critical to us with getting it, and that worked really well, better than we expected.
Tom?
So from the other side, who we want the toys, and we would love these revolutionaries, we are seeing today's toy is tomorrow's tool, and the miniaturization that we're seeing that's coming from consumer industry and from CubeSats and things like that is really important. From a behavioral point of view, if we're going to fly a $2.5 billion mission like Curiosity or something, it's got to work. There's no experimentation. That experimentation has to be done before. Yet we can't fly it if we haven't proven it. So taking CubeSats and somehow incorporating into a primary mission, but having it in such a way that it adds no risk is what we're looking at. One example, we took a little toy camera and it went from toy idea to a tool that's on a spacecraft in 2.5 months. And we took the startup ideas and just said, all right, just put it in the radiation chamber and radiate it and see until it dies. We found it could handle 2.5 times the amount it would see at Mars. And it weighed 40 grams, and it could be completely separate. Great idea to try. That would have taken a lot of paperwork and things like that in the past, but now with these partnerships that are emerging, that's really key. So today's toy is tomorrow's tool, and thank you for playing.
And I do think that story related to the Peapod is actually maybe a kind of a thought process, is thinking toward some of these, how are we going to embrace the rapid rate of change related to ground systems? Maybe there's other ideas there in terms of, somehow using that process and engaging versus, and kind of like Colonel Anton was saying, that, yeah, there's a radical idea, but, how can we use that and figure out how that's going to, help us but still stay within what we know we need to do for our mission. So very, very good point. Senor Podia talked about these mega constellations, and I think they're an example of these kind of disruptive game changers. I mean, certainly you can argue that the whole CubeSat revolution with the toys to tools is one as well. Several other things fall in that category. But certainly things like the mega constellations are going to be driving disruptions in our ground system market, and is going to be certainly a competitor of sorts for industry attention, in addition to the impact that it might have on government and the enterprise ground. So how do you think you can leverage this market disruption to build future ground services, ground systems that are revolutionary and can kind of serve to be our next generation ground systems? You want to start with that, and then we'll get others to talk to it as well?
Yes, I can maybe start. Well, in our case, what we are trying is to streamline a lot of the things that we do. We, of course, with these mega constellations, the requirement on the level of automation of the system is way higher and becomes more and more important. We know that today we serve some telecommunications satellite operators that fly relatively large fleets, but we're talking about maybe 30 spacecraft. That is the case of Eutelsat, for instance, that we serve them. But this is 2 orders of magnitude bigger. So the level of automation, and in the case of Eutelsat, they operate this large fleet with only 2 operators. This is what they have. Now, with OneWeb is, as I say, is 2 orders of magnitude difference, so the level of automation that we need to implement in the system is much bigger. There is an operations concept that needs to be designed, and this is something that, in fact, the operator itself has to think a lot about how to operate such a large fleet. There are 20 orbital planes. You may design to control per orbital planes. The displays also need to be redesigned completely. How to put on a screen information of thousands of spacecraft in a sensible manner that makes sense from an operational point of view. So there are a lot of technology development that needs to be done. And I wish that the government programs would pay more attention to this level of innovation before the actual thing happens. And I think that there is more technology research on our domain that I encourage the government agencies to pay more attention to it.
Well, certainly, I think with a lot of the talk about resiliency, some of the architectures for SMC have maybe not mega constellation, but certainly have talked about disaggregation and certainly definitely a different scale than what we're talking about now. So any thoughts, Colonel, in terms of government approaches for that, in terms of kind of thinking forward if we were to have more of those type of much larger constellations?
Yeah, certainly in the area of mega constellations and their use, we're seeing a lot of push toward distributed ground station activity, and automation is the key to this. And so if you step away from our own business and don't think about this as space, a lot of people have already sort of tackled this. And so banking is actually a very interesting place to look for distributed automated processing capability. Cell phone systems and cell tower systems very similar. So if you want to have a network which communicates with satellites in a distributed fashion, you certainly need to start thinking about it now. And that's an area of interest, I think, in my area of advanced systems and development that we're interested in as well.
Very good. Any other thoughts on the, Tom?
I think that's an excellent question. And if anything came out of this conference, it would be that future architecture. What does it look like? Mm-hmm. And I think it would have these, at least these components. I think it would have cloud and clouds for scale. I think it would have software containers for portability. You'd have microservices for redundancy. And that's how you build that if one worker doesn't finish, somebody else picks up automatically. You'd have machine learning that's coming out of industry for orchestration and changing and cybersecurity awareness. And it would have scripting and programming for automation. And if there were something that stitched all of those pieces together and you could have a small, medium, or large, I think that would be exactly what we need.
Yeah, very insightful. Absolutely. Can't write fast enough there. Very thoughtful. So one question that came in for Jordi specifically was, and I think also because in addition to the defense applications, we also, of course, have planetary systems represented here. So anybody working on any planetary CubeSats that you know of?
Yes, yes. There are actually a lot of activity. Marco was the big one that was going to fly with InSight as an interplanetary relay system. There's a few moon missions, and there's a lot of interest in the ability to do measurements that cannot be done with a bigger spacecraft. One of the big things that we're finding is, if you want to, we had a proposal at TIVAC where we were looking at a lunar mission where the measurement is the best place to get it is anywhere between 100 meters on the surface of the moon. And that's very difficult to do with a big spacecraft because you're going to break it. So we took the approach, which is kind of where that radical thinking goes. We'll break it. We'll just shoot CubeSats into the moon and crash them, and then they'll get the data right before they hit the ground. So we're seeing a lot of that kind of stuff coming along on the interplanetary realm, where I don't see CubeSats for a long time being the primary vehicle, I think what we're going to see is CubeSats being carried places by primary spacecraft. The other thing that is difficult from a ground infrastructure is the deep space network is highly subscribed, is extremely expensive, and there is no very good way of making it cheaper. And if you put 50 CubeSats in Mars and 20 in Venus, and you start telling the DSN guys that they have to track them all, the cost just goes nuts. But if we have a big spacecraft that does the relay services, that works very well. So I think we'll see some of that stuff. But JPL is running the show on that. ESA has also an asteroid mission now with CubeSats. So we see that becoming more and more of a thing. And you probably should say that.
I want to talk a little bit about Marco, because Marco it's a CubeSat, it's a toy, but it became a mission that's very valuable for it's about a tenth of the cost of a small satellite from before. So it was a startup way. Okay, you got about a tenth of the normal time. You got a tenth of the normal budget. Go build it. So how do you build it? You build it differently. And what we're seeing now is all these ideas are popping up from the crowdsourcing of ideas with CubeSats. And it's driving new use cases, actual real use cases. So it's driving the miniaturization of the instrument. Scatterometer used to be this big, now it's going to become this big, and now you can put it on the CubeSat. So all of a sudden, the real science you can get from an instrument, the instrument is getting smaller and smaller and taking less and less energy. And energy and weight is the big problems for us. And then having the relay ability is really key. So we already know how to do that, and it's just going to be magnified because we'll have a lot of CubeSats out there. But it's a wonderful time to experiment and try things.
Thanks. Well, there's one topic we haven't talked about yet today, but it was definitely in terms of several other sessions. There was a working group on it yesterday as well, too. So it is related to embracing model-based systems engineering or model-based engineering techniques as part of future ground systems. So the question is, what are your thoughts on how to encourage organizations and program managers to adopt MBSE tools for ground systems SE? Should system engineers get out in front and start employing these tools to show the long-term benefits? And have yourself had any experience in terms of utilizing any of the MBSE on ground systems? Anyone like to start with that question? Tom, I know JPL's done some MBSE stuff.
So we've been talking about model-based system engineering for a long time, and finally it's actually taking hold. And I think it's taking hold because we're talking about the benefits of model-based system engineering, not the technology. The technology we'll figure out, but it's really about being able to go away from drawings and being able to use a model, build a model, fly the model, crash the model, rebuild it, before we actually bend any metal. And somebody who's really good at that is the car industry. They do model-based system engineering already.
Right.
Remember one time I had them to JPL, Nissan. I was going to impress the heck out of them. It went exactly the other way. They were way ahead of us. So there is a lot we can learn, but now we're actually thinking about it from an end-to-end. And if you build, we have a hard time reusing because we go to places that we've never been before. But if you can reuse components of that model and show how they're reused, in a new proposal, for example, that's an end-to-end model-based engineering, model-based system engineering. And I think we're finally getting there, and the tools have caught up. So it's something everybody's focused on now.
Yeah. How about in the European community?
Well, yes. In our case, we're following. In our case, we're following the ESA leadership on this, and ESA is really pushing hard on using model-based engineering models and in our systems. And yes, we are following their leadership on this. Okay.
Let me say something
Sure.
maybe
Sure.
controversial.
Yeah,
I'll just say
absolutely.
And one of the things that we're seeing is models in the computer are becoming a really useful thing. But I think one of the things that we're starting to see is that things like 3D printing and other
yes.
rapid prototyping things are making building the actual thing really simple.
Yes.
So I don't know where we're gonna head. And CubeSats have been one of those things where it's like it's cheaper to fly it than to do all the analysis and the testing on the ground. So I see that as a kind of a counterpoint to system-based or model-based systems engineering, when you can actually go build it so quickly that you may you may actually do prototype-based systems engineering, or it will have a different name. But that's a change that's coming.
Yeah, no, I'm actually glad you brought that up, because actually very related to that is the whole additive manufacturing and the smart manufacturing and everything. So no, that absolutely is kind of on that future trend list. It could very much change how we do things in the future. We're getting toward the end of our panel time, but I do have one last question that I would like each of our panel members to think about and respond to as we finish up here. Certainly our theme was, embracing the rapid rate of change. That was our theme for all of GSAW and the theme of the panel. And so in thinking about your current role, your career, and then, fast forwarding future in terms of 5 to 10 years forward, what would you identify as kind of the one change or the one idea that energizes you in terms of going toward the future? Or on the opposite side, is there one thing that as you think toward where you want to go that maybe worries you the most or keeps you up most at night? So that kind of one thing, thinking toward the future, embracing the rapid rate of change, what is that one thing that comes into your mind of something either that provides energy and or that you worry there might be a barrier that you really feel we need to think about? So why don't we start at the end and we'll work our way down here. So Tom?
So I would think the thing that energizes me more than anything, and it's never been a better time to be in IT, except the next IT decade, is the rapid rate of experimentation. We used to think that we could have some smart people think it all the way through and go in a serial waterfall approach. We now know it doesn't work. We have new tools that come up all the time, like 3D printing. We're now 3D printing robots that fly, that climb, that fall, that survive for pennies on the dollar. So it's the rapid rate of experimentation and bringing in the next generation of explorers and having them. We used to think, training program would be okay to take 3 years because they would stay for 30 years. It doesn't happen that way anymore. They're going to stay for 3 years and then they'll be off. So we have to have them hit the ground running and be productive. And as soon as they start, we have to now start backfilling. So it's a very different way, but it's that rapid rate of experimentation that is the maker movement. It is that people want to create a startup, so let's build startups inside. It's that thing that energizes me, and I think has a huge amount of hope for our future.
Thank you. Tom. Jordy?
I'm in the same boat. I think the thing that the thing that is really exciting is for a while in aerospace, we were working on this industry. We are the aerospace industry, and we do things this way. And right there, we were watching the commercial electronics industry just go nuts. And it was like, wow, isn't amazing at what they can do, but it's different because we are aerospace. And I think that has changed. And I think back then we saw that as a bad thing. They don't have the quality, they don't have the reliability and all that. But I think people realize that your phone works most of the time. And we're embracing that. And that change coming to aerospace, I think, is really, really exciting because they have billions of dollars to develop new chips and new technologies. And we finally are allowed to go play with those and grab them and put them in our system. So that's really exciting. The other thing that I see, and this is both a blessing and a curse, is that this is a global phenomenon. And right now we've seen, there's a CubeSat startup in Colombia. They're building satellite components. What are they doing? South Africa, all these different countries. And what we're seeing is those people have different needs, different problems, and will come up with unique solutions. And that's great because we'll have this new innovative force joining the effort. But at the same time, they're going to be a competitive element that we have to deal with. In the previous years, if you want to be Astrium or Boeing and build GeoBirds, you need billions of initial investment. Nobody can play in that. It's very difficult. But if you want to build the next CubeSat instrument, a few guys in a garage somewhere in India can do it and do it better than we do. So that competitive atmosphere is on one side really exciting, but on the other side it should be terrifying to some of us.
Thank you. Jorge?
Yes, so from my side, what energizes me the most is challenges, and to have new challenges to feed the talent of my people So this is first and most important. And challenges come from these mega constellations that I mentioned, but also from CubeSat missions, from lunar missions, Mars, and there are many others type of challenges that energizes us as a company and as individuals. And I would like in my last statement to recap on the responsibility that the government agencies have in this business. They are by far the driving force. They manage budgets that today are way beyond the commercial market, and the ability of us, the industry, to invest in addressing those challenges requires the government agency support. Otherwise, today, the business case doesn't close. The market is still too small for this to happen. So my last word was this: there's a responsibility on the government. I truly believe a lot in the ability of the industry to generate innovation, and I would like the agencies to rely more on the industry and to delegate more responsibility to industry and to create the conditions for this ground segment market to be more open to industry innovation.
Good. Thank you, Jorge. Michael.
Ditto. Excellent point. So the excitement comes, I think, for me in really contributing and being a part of missions that matter. When we look at what our customers are trying to do and the things we can bring to make those things possible, it's really rewarding to see the opportunities that are emerging in the IT industry and the necessities that our various customers have in accomplishing their mission. So I find that a super exciting part of it. The challenge, of course, is the innovation it takes away from the technical part, the innovation in changing reality and to deliver capabilities that industry can continue to grow and develop and advance that are really serving that mission space. And as we talked earlier, the cultural dynamics about how we, on the industry side with our government counterparts and in our broad commercial base, how do we leverage that advances, how do we create the advances in the environment and an environment that is rich in that? The government's role is substantial and can tip the balance to create excitement that is not sustainable, and then it's that, or excitement that continues to grow and really accelerate. So I think there's an opportunity for that accelerating point, and but I think that's the real big challenge.
Thank you, Michael. Rispa.
So what excites me the most is the fact that we can actually have the power of the spacecraft in our hands now and take a new way of selfies, right from up there. So that's what excites me the most. But there's lots of challenges for us to get there. One thing that I would really like to see is, the access to space increase to, kids, elementary school kids, and so on and so forth. And, we as the aerospace industry have contributed so much. So I'm really excited to just kind of go forth and see what the next big thing is here.
Okay, Colonel Antonin, we'll let you have the final word.
Thank you. So the thing that excites me the most is if you look back at the last decade, the change that Jordy and the other pioneers have made, they have birthed a new industry. Mega constellations are even being considered now because somebody went out and built a CubeSat for $200,000. That broke the cost model on satellites and started driving behavior that is emerging today about what the cost of satellites can be and what they can therefore do. That paradigm shift is going to enter into a next shift that's also very exciting, tied to how satellites themselves are built. Today, I think Jordy's heard me say this before, we build satellites the same way we bake cakes. You get all the parts, you bring them into an expert chef like himself, they put them all together, and out pops a great cake. That's not the way anything else is built that matters today in industry. So how we construct them, how we use them, how we take 3D printing and maker manufacturing and turn it into assembly lines that turn out satellites that have higher reliability, that are part of these mega constellations, is going to be that next hugely exciting revolution. The thing that keeps me up is where that then leads. Right now, we send balloons up into space, and they sit there very quietly, for the most part, and do what they're told. The next revolution is maneuver. When you can move, everything changes. When you can go to another planet and you're not NASA, everything changes. It changes the way we do ground system. It changes the way we look at satellites. It changes the safety. It changes the future. And so as maneuver becomes a common part of every satellite, and frankly, you can build a CubeSat today for a couple $100,000 that can maneuver to the moon and back. When that becomes the common and our little balloons are no longer safe in space, that's what keeps me up at night.
Thank you. Thank you, Colonel. Well, I want to thank all of our panelists. Just an amazing array of perspectives and insight. So I want to thank each of them for coming today, spending time with us, and responding to all of your questions. So please join me.